The topic is that using PV power to heat up the water. So it's an interesting topic which is quite being uh, topic in the Benelux market, and so do in the different regions of the countries. But let's start from the introduction part from my side. My name is Talal. I'm handling the technical sales from my PV, and for a number of years I have been handling technical sales. And then we have our let's say founder members, Dr. Gerhard and Marcus, where they have founded this company using their experience from the PV inverters, and now they have been able to establish my PV. So my PV is relatively young company. We started our history, let's say to be exact, from 2013, where we launched product into the market, which we will be discussing today in this webinar as well. So there our milestones begins with DC products, the AC products, the single phase and three phase products. So those were, let's say, our different products, but all of them are focusing the PV systems that use for heating up the water. As a company, we are an Austrian company. Those who know Linz or Vienna, we are close to Linz, to be exactly in the province of Upper Austria. So the company itself is based in Austria. On the left, you can see the building covered with the panels. We are doing heating application in this building, and all our support R&D is based in Austria. And on the right, you can see our production facility. So the products are made in Austria, and you can be assured of the quality that sells by the name itself. So now I will just hand over to David to introduce about yourself, the company, and then we will start this webinar.
Thank you so much, Talal. Hello, everyone, and thank you for joining this joint session between MyPV and Goodwe. My name is David Wijnands, and I'm the Customer Success Manager at Goodwe. It's great to be here today alongside our colleagues from MyPV to talk about how our technologies complement each other and helping the homeowners to get the most out of their solar energy. In my part of the webinar, I'll briefly introduce who Goodwe is, share some highlights from our product portfolio, and explain how our hybrid inverter technology and energy management systems work seamlessly with MyPV solutions to create intelligent, self-sufficient homes. Goodwe and MyPV share a common vision, and that's empowering homeowners to use more of their self-generated solar power instead of exporting it to the grid. And our hybrid inverters communicate directly with MyPV. Um, and this collaboration ensures a seamless handover between solar production, battery storage, and solar heating or water heating, creating a complete energy management solution. Goodwe was founded in 2010 with one clear mission, and that's to drive world's smartest energy future. Since then, we've grown into one of the leading global inverter manufacturers with over 5,000 employees worldwide, more than 1,000 research and development engineers, and over 200 overseas staff dedicated to local support and services. And we established our European headquarters in Munich in 2018. That was a major step in strengthening our presence in the European market. And over the years, our milestones included we had the first hybrid inverter in Asia. We became Europe's number one hybrid inverter supplier, and we evolved from a hardware manufacturer to a comprehensive energy solution provider, offering solar storage, EV charging, and smart home technologies. Our European footprint is growing rapidly. We have now strong local teams for sales, technical support, and training in multiple regions, including the Netherlands, Germany, Italy, Spain, and more. The European market is also where our hybrid portfolio is most successful, particularly in residential storage applications between 3 and 30 kilowatts. Oh, yeah. This is the foundation of many smart energy systems we see today, including those where Goodwe and MyPV technologies work together. I will hand over the mic again to Talal.
Perfect. Yeah, perfect. So exactly, we will be discussing how both products can be integrated together with the, let's say, under this intelligence of the system. So let's discuss what my PV is doing specially. So when PV comes to your mind, the first thought is that you are doing EV charging or you are doing the house load. So those are the typical applications. But what my PV is suggesting that yes, you can do that as well, and plus you can also do heating application by using PV power, and that's our focus. So my PV is focusing on the heating application. That can be domestic hot water, that can be electrical space heating, which I will be discussing in the coming slides as well. But now we know, okay, we are focusing the heating application by using PV power. And then question comes, where do our solution fits perfect? To categorize them easily, the one option or one core area of our focus are the single family homes. Yes, there are commercial applications, but the primary uh, users are single family homes. In that, we categorize in old constructions and where you have poor insulations, and in that you can estimate that yes, your domestic hot water energy demand and then the space heating demand. What my PV recommends is that yes, you can do domestic hot water by using my PV as a solution, but space heating is really not recommended in the old buildings where your energy demands are really, really high. Yes, you can technically do it, but power from the PV will not be enough to heat up the space in the old buildings. But coming to the modern houses, low energy houses, passive houses, there your domestic hot water demand and space heating demand is more or less the same. And there, yes, you can do electrical space heating, meaning infrared panels, electrical floor mats. Yes, you can do that with my PV. So in the new buildings, yes, you can do both things, domestic hot water and as well as electrical space heating. But in the old buildings, it's important to note that the application makes sense only in the case of domestic hot water. What we visualize as a heating principle is that yes, we are using external sources for heating up the water. That can be oil, that can be gas, that can be pellets. What we are seeing is that yes, during the day, use power from the photovoltaic as much as you can, and during the night, yes, you can use power from the grid to heat up the water. When we discuss about the storage from the PV, because this is connected with the PV, so you have PV power, you have excess power. Where do you put that? Yes, you can put that power into the battery, but still the per kilowatt price is expensive for the battery. What we are saying is that you can store more amount of your power in a 300-liter boiler, for example. Yes, you can store more amount in the boiler, but just as a complementary, that our products are also compatible with battery storage, just for example with the Goodwe hybrid inverters. So those are the things which we can work together as well. But just to give you an overview that battery storage is still expensive, but both systems work together as well. So the topic for this webinar will be those products which work with the Goodwe. So we have our AC products, the AC Elva 2 and the AC Thor, which uses the excess power from your photovoltaic. And those products can be integrated with Goodwe PV system. The question comes, why do you need such product? Why do you need, or why we are saying that you need to heat up the water? The reasons for that can be number of reasons, but let's draw down to the important ones. For example, the feed-in tariff. So in many European countries, for example, in Belgium, it's already there. In Germany, it's already there. In Netherlands, it's coming up that you have low feed-in tariffs. So it means that when you export your surplus power into your grid, you are not earning anything from that. You are just wasting that power and sending that power for free to the grid. What we are saying is that yes, you can use that power at the house and increase your PV cell consumption. Other issues, yes, grid stability is related to that. For example, in Netherlands, there's too much PV power in the grid, and that's causing this grid stability issues from the energy providers. So those are the reasons to choose it. So as we already know that we are using the excess power, so just to have a concept more clear, that you have PV inverters and then you have AC power that you are being using that in the house, and there comes a moment when there's a excess power. So either that excess power goes to the battery, so once the battery is full, then my PV diverts that excess power to heat up the water. So we are exactly using that excess power which is being wasted, which is being sent to the grid, and we are precisely using that power to heat up the water. So in that scenario, we have our first product, we call it AC-LVA2. So this is the second generation of the development. The first generation was produced in 2016, and this generation has been produced in 2024 last year. And what it has more, or what this device is doing, we call it all-in-one solution. What it means is that the heating element along with the power manager or the controller both are attached to each other. So for installers, for plumbers, this makes job easier because everything is just together. If we discuss more into details of this product, here again the schematic, if we look into, we have a PV production from the PV inverter. In this case it's Goodwe, and we are continuously communicating with the Goodwe inverter that hey, what is excess power, what is going to the grid. We are measuring that very precisely and very quickly. Roughly the speed is 1 time per second, so imagine that's very quick. So whatever power is being sent to the grid, we are reading that power, we are reading that information, and that information is received by AC-LVA2 in this case, and we react to that very quickly. What it means is that we are doing a linear power control from 0 to 3.5 kilowatt, 3500 watts. Whatever power is in between available, we are diverting that power. That power, for example, in 1 second, it can be 100 watt, next second it can be 300 watts. So it's continuously changing. The power is continuously changing in this scenario. So this increases the saving. So no watt is wasted in the case of AC-LVA2. If we see what other features, for example, is this, yes, from the previous generation it has more power capacity, it has color touch display. So for commissioning and having an overview of the device, it's really helpful. The device itself has different communication possibilities, Wi-Fi, LAN connection and RTU connections are there as well. Yeah, again on the point of communication, which is the integral part, how it gets information from the Goodwe. So in the case of Goodwe, we are receiving that information via Modbus TCP, and both system need to have or should be in the same network. So that was about ACLWAT2. So it's a linear power control device that uses all the surplus power and diverts that power to heat up the water. So it's aside from it's not doing let's say it's not working on relay or switches like that, rather on the variable power. So the device itself is being using PWM sine wave, so that is a sign of quality as well. And another thing, sometimes users are asking, okay, do we need to have a particular boiler for ACLWAT2? We go some slides back. So here the answer to that is, yeah, you do not need to have a particular brand of the boiler. Rather, what you need is that there should be a minimum diameter that can have the heating element, so meaning 46 centimeter roughly, and then you need a thread size of 1.5 inch. So these two are the points which you need to consider in choosing a boiler for ACLWAT2. We have interesting case study as well. So this installation is from Netherlands, and the interesting thing about this installation is that there is a battery system, there is a big PV system, and what was happening before my PV was that the user was putting a lot of surplus power into the grid. And since there are some grid fees, so the customer needed to pay a lot of grid fee in this case. But things have changed since then. He has now installed a 200-liter boiler with the ACLWAT2. So what happens is that once the battery is full, then we start, or the ACLWAT2 starts to heat up the water up to 80 degrees centigrades. So this has increased the PV cell consumption a lot for the user and help him avoiding the grid fees. Yeah, again, some highlighting on the PV self-consumption. As I already mentioned, that without any PV self-consumption solution like battery or my PV, your self-consumption for, let's say, an average system is 6 kilowatt, your self-consumption is below 30%. But yes, you can increase your PV self-consumption with the battery, but that comes at the cost. Still, the capital cost is quite expensive. But what we are saying is that you can combine my PV with the battery and increase your PV self consumption up to 90%. So those are the possibilities as well. And already explained this in this reference case as well, that yes, our system works with the battery storage very successfully. What happens is that till noon the battery is full, and once the battery is full, ACLWA2 starts diverting that power into your thermal storage. So that's how it works in the scenario. And we also have a planning tool. So this planning tool is free of cost. You do not need any registrations. What you can do with this tool is that um, you can give in the parameters, for example, how big is your PV system, your electricity tariff, your feed-in tariff, how big is your how big is your boiler, how many liters, how many people are in the house, and at the end you can make a comparison with your conventional system on your savings, so you can estimate paybacks, and all this report can also be printed as well, so you can make a report out of it. Then we look into our other products. So the concept is the same as with the AC Elva 2, the device which has the heating element. So now imagine that the part of the heating element is away and there's only a controller. So that controller would be called AC-Tor or AC-Tor 9S. So the terminology being used for such controller is solar power diverters. So these diverters are more flexible in terms of application. Why I'm saying that is that EC-Elva 2 is only for the application of domestic hot water application, but AC-Tor is more flexible in terms of application. The reason why I'm saying that is, let's see into a schematic. For example, here you can see, or in imagine there's already a immersion heater in the boiler. There's already a heating element in an electric boiler. So in that case, it doesn't make sense that uh, you bring out you bring out the heating element outside. Rather, you can connect the existing heating element with the AC-Tor. So that is the flexibility which AC-Tor offers, because in many cases there are already immersion heater in the electric boilers. Plus you can do space heating with the AC-Tor, but I will clear that in the next slide. But just giving you a feeling that yes, in terms of application, AC-Tor is more flexible. In AC-Tor, we have two variants. We have a single phase variant. Since Benelux is mostly single phase, so single phase I would say is more popular compared to three phase, where you can, so on the right it's three phase. Here you can do a linear power control from 0 to 9,000 watts. So that is a possibility with the bigger device. But in the case of smaller, the AC-Tor, the single phase, there you can do a linear power control up to 3,000 watts. On the bottom, you can see all the connections, for example, the Ethernet connection, the temperature sensor, and other contacts can be directly connected with the AC-Tor. So it comes with all the plugs. You do not need any you do not need to open any terminal box. Rather, you can just plug or insert the cable in, and that's it. In terms of operation mode, yes, it depends again on the application, what the user is looking for, but majority of the application is just the hot water. That's the number one application being used. But yes, there are scenarios which can be possible, for example, combining with the heat pump, which I will also discuss in the coming slides in the reference case. And then we have other scenarios where you can combine AC-Tor with hot water and as well as with space heating. So there are different areas of applications. And yeah, continuing further, for example, as I already mentioned that the AC-Tor is the same as terms of controlling, but here the flexibility is the load. If there's an existing load that can be connected with the AC-Tor, and it is equally equally it can be integrated with Goodwe as well. So there's no difference in terms of communication. It works perfectly fine, and we have been in partnership, I think, for roughly now years, more than that, and it's working perfectly. In other case of application here, for example, this is a bigger device with the AC Tor 9S, which has three outputs, and here you can see one output is being connected with heating element. The second output is connected to the electrical space heating, and the third output is connected to the infrared panels. So there are these possibilities, but this only makes sense when it's a new construction. It's a passive house where your energy demand is low. Yeah, again, in terms of communication, just like its brother, I would say the ACL2, the communication is based on Modbus TCP, and that's how it works with the Goodwe. We have a case study as well from the Goodwe, which is being used since 3 years now, in my knowledge. Here, the interesting part is that there is a PV on the rooftop, which is 6 kilowatt system with the Goodwe, and plus there is a battery storage as well. So in terms of storage capacity in the boiler, there's a 500-liter boiler which has 6 kilowatts. So imagine you are filling up the battery first, and then excess power goes into your boiler, and you store that 6 kilowatt into the boiler. So increasing PV self consumption in this case was more than 30% in the peak days. And what the customer was able to achieve was minimizing the gas consumption. Yeah, some more interesting case study across Belgium. Here there was a pellet heating, so the user was able to avoid pellets during summer, during spring and early autumn period. So AC Thor was completely able to heat up the water by using power from the photovoltaic. But let's discuss in terms of technicalities. Yes, from technical point of view, you will get the slides, and we will be sharing the slides after the webinar. So all the data sheets, all the operation manuals are linked in the slides as well. And one interesting point which I wanted to highlight, that there are some markets across Europe, especially in some regions of Belgium, where they have three-phase delta grid. For them, I can only say yes, our three-phase solution cannot be used, the AC Tor 9S. Rather, our single-phase solution can be used in that scenario. That can be AC Tor, that can be AC LWAT2. So there are these possibilities. Further, in terms of integration, we have our Goodwe instruction manual, where we have described step-by-step approach in terms of compatibility. For compatibility, it is important that the Goodwe inverter and my PV device should be in the same network, and from the settings where we choose the control source where the information should come for the excess power, there you simply need to choose Goodwe, and then you just put the IP address for the Goodwe inverter, and that's it, and you start getting the information from the inverter. So further, I will just pass the ball to David. David, looking forward to hear from you about the Goodwe portal, how different variations are there. So looking forward to hear from you.
Thank you so much. Yeah, this is our residential energy storage solution. Our hybrid inverter range is designed for flexibility, reliability, and intelligent control. We cover a wide range of single phase and three phase systems to fit almost any residential setup. Each of these inverters also include built-in energy management functions, remote diagnostics, and firmware upgrades capabilities, and they are all managed through our own SEMS portal. Let's turn on the pointer. I will take a deep dive in the hybrid inverters. Let me highlight this one first. This is our balcony storage solution. It's a 800 watt battery module. You can use it as a plug and play battery, but you can also put it on a separate breaker and you will have 1.9 kilowatt hour storage solution. It's designed for easy setup and use, and it requires no complex electrical work. The deep dive in the hybrid inverters. Our main focus is on the ET series. They are designed for residential homes, and they are compact, efficient, and MyPV ready. Here you say this is the three-phase solution. We also have a three-phase solution for the smaller households with a power of 5 to 10 kilowatts. And we have the single-phase solutions in a high voltage and in a low voltage form. The differences between these are we also have retrofit abilities. You will encounter households who have a we already have an installation, and it could be an on-grid inverter which isn't hybrid. You can also choose our BT series or BH series depending on if it's single phase or three phase. Our EH and BH series are the high voltage one, um, and the ET series G2, uh, they are designed for larger homes or small commercial buildings, and the ESG2, that's our low voltage. Um, And importantly for today's discussion, these inverters are all compatible with MyPV systems. With the hybrid inverters, um, we also give the opportunity to connect a battery system. Um, Goodwe offers high and low voltage storage options, all based on LFP batteries. They are for maximum safety and longevity. The Lynx Home U is our low voltage one, single phase. You can connect up to 6 units parallel, and you can go from storage capacity from 5.4 kilowatt hour to 32.4 kilowatt hour. Our main battery at the moment is the Lynx Home D. It's 5 to 40 kilowatt hour. It's a modular range, so you can stack them. On this picture, you see two modules on top of each other, and you can increase the capacity if necessary. And by combining these batteries with our hybrid inverters, we also create the foundation of a smart, self-sufficient home energy system, and one that can dynamically manage solar power, storage, and load control. Our ACH G2 AC EV charger also integrates seamlessly with our inverter ecosystem, supporting dynamic load management and smart charging modes. It's available in 7 kilowatt for single phase, and it's available for 11 kilowatt and 22 kilowatt for three phase. It allows users to charge their EV directly from solar and maximizing green mobility. And it supports RFID access, remote updates, and communication with the inverter. And it enables the balancing of the load distribution across the household devices. And this also contributes to one central goal, and that's why we are all here. It's to maximize self-consumption and reducing grid dependency. The same goal that connects us with MyPV. The Goodwe Plus installer program. That's a program we supply to our installers across Europe by offering warranty extensions from 5 to 10 years for all on-grid inverters up to 20 kilowatt hour, access to dedicated support channels, training, material and marketing resources, and you will also be eligible for exclusive promotions and technical updates in our own database. And the only thing you need to do is register the inverter on the SAMS portal to activate these benefits. Our balcony PV system. This is integrated in our balcony storage module, which I highlighted in the slide. The Goodwe Suncake is a portable plug-in balcony solar system designed for easy installation. It's lightweight and a complete kit that includes PV panels, a microinverter, and mounting hardware. And it allows household owners to generate their own electricity by simply attaching the panels to a railing, plugging the system into an outdoor outlet, and the system is designed to be flexible and versatile, and oh, it's also designed to be expense to be modularly expanded on. So if you also have the all-in storage solution, you can plug in the Suncake into the battery system, and you will also have the storage solution. These are communication devices, mainly focusing on the Wi-Fi LAN dongle. We also have a HomeKit smart meter logger. If you have any questions regarding that, contact us and we'll give you more information about it. SolarGo is our commissioning app, and SAMS Plus are the monitoring platforms, so you can keep an eye out on your production and your usage levels in the household.
Perfect. So I guess we are good in time. So continuing further, I think just adding some more points from my PV. So we have our own cloud as well, and this can be very beneficial, especially for the installer. So once the device is online, the installer can fix the parameters remotely on his laptop or on the mobile phone, and this is very helpful in terms of saving the time, giving support to the client as well. It's always recommended to put the device online, so in case of any failures, our support can help in the best way possible. More on this connected with the cloud. So our cloud has many features, and one of the feature is that there's a possibility to do dynamic pricing. What it means is that our cloud our clouds get the information one day ahead that what will be the market pricing per kilowatt for the residential units. So for those customer having dynamic contracts with their energy providers, they can heat up the water by using dynamic pricing. So whenever the price is cheap, yes, during the night we will take full power. Our devices connected with the cloud will take full power and heat up the water on the cheaper rate. So this is really beneficial, especially for the winters when there's little availability of the sun, and in this way it can be heated more economically. So more on the suppliers. So we are always open in terms of cooperation. So we have different trade partners across different regions, and you can always check on our website where to buy my PV. Yeah, further in terms of support, yes, we have a ticket system, so the user can fill in his contact details, the device serial number, what's wrong with the device, and our support team will do their best to reach you as quickly as possible. And yes, we are at the end of the webinar. So we are open for the questions. So if you have any questions, you can drop down in the chat as well. And as already mentioned, you will get the slides from us. You will get the contact details from the David as well. And so far everything looks good. We are good in time, so we will keep up open. Maybe ending remarks from your side, David?
No. I really want to thank you for the opportunity, and by collaborating, and together, yeah. Thank you very much for your attention, and I look forward to hearing from the chat if there are any questions.
Okay, so far it's silent, so maybe from my side, have a nice evening, guys, and I will leave the chat open for some time, so if there's a question we can get back to you. But from my side, have a nice evening, and wherever you are, stay healthy.